Okay, so now let's move on to section 1.5. It's called Quadratic Applications. In this worksheet that I have in my notes, you could also find in the supplemental materials section. So let's go through this. For problem number 1, it says a rectangle. Okay, so let's just draw a rectangle. It's a good looking rectangle. Has an area that is numerically twice its perimeter. If the length, so we have length and width, if the length is twice the width, so the length is 2 times the width, that's what the problem says, what are its dimensions? Okay, so I'm going to write 2w there because that's the length on that side and w on this side. So it says that our perimeter and area, okay, and it says a rectangle has an area that is numerically twice its perimeter. So whatever the perimeter is, the area is 2 times that. So 2 times the perimeter is equal to the area. Okay, well, the perimeter would be the widths, right? So we add up all the sides. It would be a width plus a length plus a width plus a length. And the area of a rectangle is just length times width. Now, we know that the length is 2 times the width. That's what it says right here. So let's make that substitution. Instead of L, we're going to write 2w. So we're going to have 2 times w plus 2w plus w plus 2w is equal to L again, right? So that's 2w times w, or 2 times 6w is equal to 2w squared. Or, I'm running out of room here. Let's continue it right here. This says 12w is equal to 2w squared. Well, generally the way that we solve quadratic equations, we already talked about this, and we have a few tools. So to solve equations, first step generally is if it's like simple, like a linear equation, we could just go ahead and do it. Like if the problem is x plus 2 is equal to 0, you bring the 2 on the other side. But the next step, if it's not simple, we've been talking about factoring. And factoring, there's 4 components to that. We've talked about that a few times. If the problem doesn't factor, then we look to complete the square. And if you don't want to complete the square, we also talked about what's called the quadratic formula. So those are the tools we have at our disposal here. So this isn't a simple problem. Let's try to factor it. I'm going to bring the 12w on the other side. So we get 2w squared minus 12w is equal to 0. We could take out a GCF of 2w. And we get 2 answers using the zero factor property. We get 2w equals 0, so w is 0. Or we get w minus 6 is 0, so w is 6. Well, we have to have a width, right? So it looks like the only answer that makes sense is if w is 6. And if w is 6, we could plug that back in. 2 times 6 would be the length, which in this case would be 12. Let's move on to number 2. Number 2, it says the volume of a 15-ounce cereal box is 180.4 cubic inches. The length of the box is 3.2 inches less than the height, and its width is 2.3 inches. Find the height and length of the box to the nearest tenth. Okay, so when we have a 3-dimensional shape here, I'll just draw out a picture. Something like this. Our volume is equal to the length times the width times the height. Or let's call length times width times depth. Doesn't really matter. In this case, it says that that volume is equal to 180.4 cubic inches. And we have a length we have a width, and we have a height. Let's see if we can make some substitutions here. The length of the box, L, is 3.2 inches less than the height. So whatever the height is, we're going to subtract 3.2, and that's going to be what L equals. And the width is 2.3 inches. Okay, so let's make our substitutions. L, we just said, was h minus 3.2. W, we know, is 2.3. And the height, I'm not really sure, so we're just going to leave it as h. When we multiply those together, we get 180.4 cubic inches. So now we have a little bit of arithmetic to do. This is really just 2.3h times h minus 3.2. That's equal to 180.4. I'm going to distribute this. That's 2.3h squared, and then 2.3 times negative 3.2 is negative 7.36h. Now this is a quadratic equation, so I'm going to just bring the 180.4 on the other side. And we have an a value, a b value, and a c value. So I think quadratic formula would be the easiest for this. H, the height, would equal the opposite of b, plus or minus the square root of b squared minus 4ac, all divided by 2 times a. Well, I'm going to type these numbers into my calculator, and this is going to give us 7.36 plus or minus the square root, if you type it in, 7.36 negative, I'm going to square that, minus 4 times 2.3 times negative 180.4 comes out to 1,713.8. We're going to divide that by 4.6. Okay, so we'll get two answers here. One if we add, so I'm going to type 7.36 plus the square root of 1713.8, and I'm going to divide that answer by 4.6. Now just make sure you typed it in correctly. You should be getting the height is equal to 10.6. Sometimes what people do is they type it in and they don't type it in correctly, or they forget parentheses. Remember, it's the whole top divided by 4.6. So maybe type that whole thing in first, hit enter, and then divide by 4.6. If we do 7.36 minus the square root of 1713.8, and then divide it by 4.6, we get a negative height. And clearly that doesn't make any sense. We don't have negative heights. So we know the height is 10.6. We're asked to find the height, and we're asked to find the length. So if the height is 10.6, the length would be 10.6 minus 3.2, and our length would be 10.6 minus 3.2 is 7.4. Okay, let's move on to number 3. For problem number 3, it says Mike's flying a kite. Beautiful weather to do that lately. And it's on 50 feet of string. Its vertical distance from his hand is 10 feet more than its horizontal distance from his hand. Assuming that the string is being held 5 feet above the ground, find its horizontal distance from Mike and its vertical distance from the ground. So let's draw a picture. Here's Mike, and he's flying a kite on 50 feet of string. Now the string is being held 5 feet above the ground, so this distance right here is 5 feet. find its horizontal distance from Mike. Let's see here. Vertical distance. So we have our horizontal distance and we have our vertical distance. Makes a right triangle. Its vertical distance from his hand is 10 feet more than its horizontal distance. Okay, well, I don't know what the horizontal distance is, so I'm just going to call it h. The vertical distance would be 10 feet more than that, so that's h plus 10. So it looks like we have a Pythagorean theorem problem, where a squared plus b squared is equal to c squared. Well, we'll let a be h, we'll let b be h plus 10, and c is 50. So we get h squared. We're going to have to distribute this. Remember, you can't distribute the exponent, right? That's really bad. You can only do that over multiplication or division. Is equal to 2500. So this would be h squared plus h squared plus 10h plus 10h plus 100 is equal to 2500. And because this is a quadratic equation, we want to try to get everything on one side. So if I do 100 minus 2500, that's minus 2400 is equal to 0. So now we're ready for our quadratic formula, where a is equal to 2, b is equal to 20, and c is equal to negative 2400. Similar to the other problems. So let's do this. The height, I'll finish it on the side, would equal the opposite of b, plus or minus the square root of b squared, minus 4ac, all divided by 2a. This would tell us the height's negative 20, plus or minus. If you do this here, we get 20 squared minus 4 times 2 times negative 2400. That's 19,600 divided by 4. And that's going to give us two answers. If we add, so negative 20 plus the square root of 19,600 divided by 4 gives us 30 feet. If we subtract negative 20 minus the square root of 19,600 and divide it by 4, that gives us a negative height, so that doesn't make any sense. It looks like the horizontal distance is 30 feet. So what does it want to know? It's asking, find its horizontal distance from Mike. That's going to be 30 feet. And its vertical distance from the ground. Well, we know if h is 30, h plus 10 would be 40. But it's a little bit of a trick question, because remember, it was being held 5 feet above the ground, right? So the vertical distance from his hand is 40 feet, but if we add 5 to that, we get the vertical height total is 45 feet above the ground. We have one more. Joe wants to buy a rug for a room that's 12 feet wide and 15 feet long, so let's draw this out. There's our rug. It's 12 feet wide and 15 feet long. He wants to leave a uniform strip of floor around the rug. So the rug's going to look like this. It's going to go in the middle of the room, and it's going to have the same distance all the way around. He could afford to buy 108 square feet of carpeting. So that means that this area is 108 square feet. What dimensions should the rug have? Okay, well, if it has to have the same distance all the way around, let's call this distance x. And this distance is x. So the distance from the width and the length, that's going to be x all the way around. So as far as what the rug is, the length this way of the rug, or the width of the rug, it would be 12 feet. That's the whole room, but we're leaving out this piece and this piece. So if the area of the rug is equal to the length times the width would be 12 minus this x and minus this x. Now the length going this way, the whole room is 15, but we're going to be leaving off the piece like this length and this length, right? So if we take 15 feet and we take off this piece and this piece, that's what the remaining part of the rug would be. And it looks like that area, we were told, has to be 108 square feet. So now we're going to have to do a little distribution, and we should be able to get our answer. So I'm going to multiply 15 times 12. That's 180. 15 times negative 2x is negative 30x minus 24x plus 4x. And that whole thing's going to equal 108. Let's see here. This should be 4x squared, right? Let's get everything on the same side. So we wind up with 4x squared minus 54x plus 72. And now we could use a quadratic formula to finish it, where a is equal to 4, b is equal to negative 54, and c is equal to 72. So the x would equal the opposite of b, plus or minus the square root of b squared minus 4ac, all divided by 2a. And just simplifying this on the calculator, negative 54 squared minus 4 times 4 times 72 comes out to be 1764 over 8. We're going to get two answers for x. Remember, x is the space all the way around the room. So 54 plus the square root of 1764 divided by 8 is 12. And 54 minus the square root of 1764 divided by 8 is 1.5. Now if x is 12, let's think about this, right? This is going to be 12, this is going to be 12, but the whole width itself is 12. So that can't be an answer. Looks like the only answer that makes sense would be x is 1.5. So the question's asking us, what are the dimensions of the rug? Well, the width of the rug would be 12 minus x on both sides, or 12 minus 2 times 1.5, or 12 minus 3, which is 9 feet. The width of the rug is 9 feet. Now the length of the rug would be 15 minus this x and this x, or 15 minus 2 times 1.5, which would give us a total length of 15 minus 3, or 12 feet. So the dimensions of this rug would be a 9 by 12, 9 feet by 12 feet.